So in this video, we're going to be discussing our very first type of workflow, which is the augmented LLM. The augmented LLM. Like I said, some might not consider this a workflow. I think even in the standard LangGraph documentation, it is not listed as a workflow. It's discussed, but probably not listed as a workflow. But yeah, I just feel that this is the foundation. This is a solid foundation that you need to grab because it is going to be used in all the different workflows. So yeah, we actually need to spend good time discussing this. Now, what's an augmented LLM? As you all know, LLMs are basically optimized for conversation. They are just conversational tools. They don't have arms and legs. They don't have arms and legs. So they would generate responses, generate images, generate any type of content, but they can't really do anything. And they are stateless. LLMs are stateless, so they don't remember stuff. If you tell an LLM your name, and then in the very next conversation, you ask it for your name, it will not remember your name. It would not. Forget what you've been experiencing in ChatGPT or Gemini or Claude. All those stuffs are augmented. They are all augmented with memory systems, as we're going to be seeing much later in this course. So LLMs basically take in text, predict tokens that simulate the response to whatever you have passed in as a query. To make them do more, like remember stuff and even perform real world operations, you have to augment them. So any act of enhancing an LLM's capabilities, especially for it to be able to perform real world operations, is called augmenting. So you augment your LLM with capabilities that will make it function in the real world, because in the real world, we need it to remember stuff, we need it to take actions, and a whole lot more. So in this video, we're going to be discussing the different types of augmentations that you can perform on your LLM. Mainly three of them. We'll then go ahead to practice two of them, and then a dedicated chapter will be left for the third one because it's quite complicated. So yeah, the first one we're going to be looking at is the combo of an LLM and, let me just give you the background so I make it pop. So you have an LLM and tools. LLM and tools, a pair made in heaven. So this is the first type of augmentation that you can perform on your LLM. You can give your LLM tools. This then becomes its hands and its legs. They become its peripherals for it to perform real world actions. So it can do things like invoke external functions that you've defined in your application, call remote APIs and services, send emails, do all sorts of stuffs that are going to have an impact on the environment or in the World Wide Web at large. So you can give your LLM tools for sending emails, tools for sending Slack messages, tools for making phone calls, different types of tools. You can provide them to your LLM, even tools for retrieving data, retrieve data from Google Drive, retrieve data from Google Docs and stuff like that. You can augment your LLM with tools, and with that, it can interact with its own environment and also with an external environment. And LLMs are smart with this. When they get a request and they see that they have a tool to perform that request, they will invoke that tool. The LLM extracts something called a tool call object. The tool call object is then taken by the runtime. The runtime then calls the tool. So it's not like models natively have the ability to call tools. The LLM is not the one that is going to call your function. It is the runtime. Let me get the lasso tool. So it is the runtime. This box is the runtime. It's the runtime that is going to invoke your tool. So you pass two definitions to your LLM. If your LLM gets a request, let's say I need to send an email with this and that to so person, it then creates something called a function call or a tool call object. So once it gets that tool call object, the tool call object is sent to the runtime. The runtime then looks for the tool that is referenced in the tool call object and calls that tool, which will then go out, do its stuff, return a response back to the runtime for the LLM to decide what to do next. So yeah, that is the first type of augmentation that you can perform on your LLM, tool calling. Now the second one we're going to be looking at is structured outputs. structured outputs. Let's still get our box here. And another one for our LLM. So we still have LLM. It's definitely going to feature in every augmentation. So we have the LLM, and then you can augment it with a schema definition. Augment it with a schema definition to produce a structured output. Let's give these colors. Yeah. So LLM, that should remain green. This would be pink. That's good. Okay, now back to this. So you have your LLM. You can give it a schema to produce something called a structured output. Now, what is structured output? When you are using LLM in the context of a chatbot, it can work in its native language. It just needs to hold a conversation. Free-form text, produces a response in free-form text. That's all good. That's how you want a conversation to go. Nobody wants to talk to anybody and they want the person to respond to them in JSON. Nobody wants that. You want people to respond to you in free-form text. So that's all good for chatbots. But when you're using an LLM within the context of an application, of a program, you will most likely want to pass a defined data format from one component to the other. The LLM also exists as a component within your application. So if you send a request to an LLM and it produces an output, and you want that output to go to another component in your program, you most likely want it to go in the form of, let's say, a JSON object, an XML object, or even comma-separated values. You just want it to follow a particular structure. This is where structured outputs come into play. Because in your application, in fact, sometimes models will be operating within different components and sending data to each other. A model is going to be sending data to an email service. A model is going to be sending data to a Slack service, a Twitter service. You have to produce that data in the format that the destination is expecting. So, to implement that, you can simply augment your LLM with a schema. In the Python SDK, you would always use a Pydantic model. So you define a Pydantic model with fields, you use it to augment your LLM, and whenever your LLM decides to respond, is always going to respond with the structure of the schema that you provided. So yeah, that's how you have structured outputs. It makes LLM outputs usable by your applications and other downstream processes. So yeah, that's structured outputs. Now the third one we're going to be looking at is memory. Memory. So we're going to be looking at memory. So once again, we have our LLM in green. Good. And we can augment it with a memory system. So I'm just going to say, what do we call this? Memory system. So that's a memory system. So the third thing you can augment your LLM with is a memory system. And let's give this blue. Yeah, blue is good. So why would we need a memory system? Like I said, LLMs are stateless. They are stateless. When you tell an LLM something, in the next conversational turn, if you try to request that information, it is not going to be available. It's going to tell you, I don't know. You tell an LLM, hi, my name is Fikayo. Hi, my name is John. Hi, my name is Janice. And it tell you, oh, hi, Janice, how are you doing? What can I do for you today? And you're like, what's my name? The next thing is going to tell you that, as an LLM, I have no memory. It is going to tell you that. Like I said, forget whatever you've experienced in forget whatever you're experiencing in ChatGPT right now. There is a memory system behind it. So if you want your LLM to remember stuff, you need to connect it to a memory system. You need to augment it with a memory system. And there are different types of memories, as we're going to be seeing later. There's long-term memory and there's short-term memory. We're going to be seeing that much later. Now, like I said, in this section, we're going to be treating two of these augmentations, and that will be tool calling and structured outputs. These are the two that we're going to be treating. Tool calling and structured outputs. There's a whole section dedicated to memory. It's when you get to that section, you will see why we dedicated a whole section to implementing memory, because we're going to be discussing checkpointers, memory systems, saving stuff to Postgres or Redis and stuff like that. Yeah, so that needs its own section. So we're going to be dealing with memory much later. But for now, we're going to be looking at demos in tool calling and structured outputs. So in this video, we're going to be running our tool augmentation demo. We're going to be augmenting our LLM with two tools. A tool for checking the weather and another tool for calculating a tip at a restaurant. So two different tools performing two different functions. We're going to augment our LLM with these tools. Then we'll run queries through them that we know will invoke these tools so that we can get the expected output. Now, this is a new project file. So let me start by creating a new virtual environment. Since I'm in VS Code, I'm just going to use the VS Code tools and the Python extension to create a new environment. So let's create a new virtual environment running Python 3.11. And with that, I believe when I pull up my command line now, okay, my environment is not activated yet. Let's activate that. Say source venv bin activate. Good. So always make sure you do that so that you can install your packages correctly and we can operate within this virtual environment. So now we need to install three packages. We need to install three packages: LangChain Core, LangGraph, and LangChain OpenAI. Now I'm going to be using OpenAI as my LLM. Feel free to use Gemini, feel free to use Claude or any of the other models. In fact, feel free to use a local model if you know how to set it up. Just go ahead with it. But I'm going to be using OpenAI, and anytime I want to use a different one, I'm definitely going to let you know. So let's get to installing stuff. So pip install LangChain Core, LangGraph, and LangChain OpenAI. That shouldn't take a lot of time, but if it starts taking too much time, I'm just going to pause this video and come back. So yeah, our packages are installed. That's good. You can clear the screen. Now you need to also make sure that you have set the environment key for your LLM provider. I'm using OpenAI, so that'll be OpenAI API key. So just make sure that you've set the appropriate environment for your LLM provider. Else, this is not going to work. So for now, let's close out of this. And I'm going to create a file for this demo, or first a folder for this chapter. That'll be O2 workflows. So yeah, we're in chapter 2 workflows. Then the demo files are going to be according to the number of the video. So if you're looking for the demo for video 0207, just that's the file. That will be the prefix of the file. This is the third video in this chapter, so that will be 0203, and we're going to call it augmented, or rather, no, tool augmentation. Tool augmentation.py. So that's good. Now we have our file. Let us bring in our dependencies. First, let us get LangChain OpenAI in here. Then let us bring in our tools decorator from LangChain Core. Good. Now, most of the time, you can just pass simple Python functions without the tool decorator, but sometimes if you want to annotate it with some extra information, yeah, you should use the tool decorator. Yeah, but for now, let's just have it in, just for the sake of it. The next thing we're going to do, we're going to define our functions. Like I said, we want to augment these with two functions. Your tools are basically functions. They're basically functions. So we want to augment our LLM with two functions. The first one is going to return some dummy data information in JSON. And the other one is going to do some simple calculation to calculate the tip on a bill. So let us get cracking. First, let us define the weather tool. So I'm going to decorate it with tool and say define get weather. It's going to take in a city and return a string. Oh, sorry, I said it was going to return an object. No, it will just return a string. The string is going to contain the description of the weather. So let's get some doc string here. Doc strings are very, very important for tools because they're like prompt engineering for tools. So the more you describe, the more elaborate you describe your tool, the more the model is going to be able to select your tool for the appropriate operations. There are also other best practices like making sure that you name your tool elaborately. Don't do get X or get use stuff, or don't use very vague names. Use clean names that specify an action and a noun, like get weather, get a particular thing. Here I'm just going to add a simple doc string. I'm going to say get the weather for a city. Now I'm just going to construct a weather data dictionary here that will contain the weather information for some hard-coded cities. Now, in a real-world application, you want to call an API. You want to call a weather API. But for now, we just want to see how tool calling works. So we're just going to return the dummy information. So I'll say sunny, 72 degrees Fahrenheit. That will be for New York. For London, we have cloudy, and that will be 15 Fahrenheit. Then lastly, Tokyo will be rainy, 20 degrees Celsius. So we have this dictionary of weather information, and we can simply return the weather for a specific city by saying weather data dot get, pass it the city, and if the city is not available, we'll just say weather data. That's if the user requests data for a city that is not in these hard-coded options. We say the weather data not available. Good. So that's our first tool. It simply returns weather information for a specific city. Now let's define the one that calculates the tip. Call it calculate tip. Give it the bill amount. That'll be a float. Then a percentage, the tip percentage. So tip percentage, which will also be a float. And this should also return a float. Having fat fingers this afternoon. So this should also return a float. Let's go down a little bit. And for this, let us also add a doc string. You don't want your LLMs picking the wrong tool, even though in this case, that should almost be impossible. I don't know a case whereby you want to actually calculate a tip, but the query kind of gets you confused and you calculate the weather or you return the weather. That would be weird. Let's say calculate tip amount based on bill and percentage. So for that, let's just return a rounded figure. Get round correctly. So round bill amount multiplied by tip percentage, which you definitely need to divide by 100. And we want it to return it as a float in 2 decimal places. So yeah, this will be good. Now we have our 2 tools. Calculate tip and get weather. So that's fine. The next thing we need to do is to give these tools to our LLM. We need to bind these tools to our LLM, augment our LLM with tools as we have planned to do. Now to do that, first let us initialize our LLM. Now make sure you are using a model that supports tool calling. Make sure you're using a model that supports tool calling. Very, very important. If your model does not support tool calling, you might run into some issues. I don't know whether LangChain has some sort of ways to bypass or rather create a certain implementation of tool calling even if the model does not support tool calling. But we have better models today, so just use a model that you have confirmed supports tool calling. So we're going to use GPT-4o. And to create our augmented LLM, this is our plain LLM. To create our augmented LLM, we need to bind it to our tools. So we'll say LLM with tools, that's the augmented LLM, will be our LLM. Then we call the bind tools method. Bind tools. Call the bind tool method. And our bind tool method takes a list of tools. So every single tool you want to be available to your LLM, that's what you put into this list. So we have get weather and calculate tip. So this is how you create an LLM that is augmented with tools. You simply call the bind tools function on the LLM and give it a list of your tools. So our LLM is now empowered, is now smarter, or at least it can act now. Now let us test that out. I'm going to create two prompts, one for the weather and another one for the bill. So for the weather, I'll say, what's the weather in Tokyo? What's the weather in Tokyo? For the tip, I'll say calculate a 20% tip on a $50 bill. Okay, so those are our two prompts. And now we can prompt our LLM. We can prompt our LLM that has tools. So first let us pass the weather prompt. So I'm going to say response equals LLM with tools. So we invoke that. We invoke that with our weather prompt. So we invoke that, and any tool call that is returned is going to be returned in a tool calls property. This is where you find any tool calls that is returned. So let's run this first and inspect what we have. Let's run this and inspect what we have before we even get to call the function. So let me pull up my command line. Now we can run Python. Remember I said you should have your credentials for your LLM in place, so don't forget that. Your credentials for your LLM, make sure it's in place. So Python, go to the O2 folder, workflows. Then the only file that is there is the tool augmentation file. Now let us run this. Oh, okay. I just ran it, but I just realized I didn't print the results. So we're basically not going to see anything. We're not going to see anything. It's just going to return. Taking a bit longer. Yeah, so it just returned because I forgot, my bad, to print something out. So let us print the two calls. Two calls. I just wasted tokens there. So let's call this again. And here we have our tool call. We have our tool call object. Now, here is a tool call object. This is how it looks like. We only have one of it because it suggested just one tool. Based on our request, it suggested one tool. The name of the tool is getWeather. The arguments are city Tokyo, which is the only argument that our tool is expecting, which is city. We go here, look at the calculate weather method. You see that it expects city, so city will be Tokyo. And that's a tool call ID, and the type of response is a tool call. So yeah, so that's how a tool call response looks like. Now let us process it and use it to call our function. So we get this. So what I'm going to do in this case, first let us comment this out. What I'm going to do is that I'm just going to loop over the tool calls, and any tool we identify there, you should call it. That's basically what we're going to do. So I'm going to say for tool call, in tool calls, if the tool name, that is if tool call name, as we have seen in the printout that there's a name property. So if the name is getWeather, then we need to call the getWeather function. So we'll say result equals getWeather.invoke. Then we can simply say tool call and args, passing the arguments. So we call invoke, which is coming from this tool decorator on our tool, and we can simply pass it the arguments as a dictionary that can be found in the args property, and it's going to call it. Else, or elif, not L, elif, if the name, so I'm just going to copy this again, if the name is calculate tip, then we'll have to call the calculate tip. Just copy this. Need to call the calculate tip method and invoke it with our tool call arguments. Good. And then we can break out of this loop and print our results. Good. So we're just looping. Definitely we can put an else here. Yeah, let's put an else here. Let's say else. Let's say result equals no tool found. So no tool was found. So yeah, just to undo the other cases where nothing matches with our tools. So now we can pull up our command line once again and run our file. We are currently processing the weather prompt, and as you can see, we queried it for the weather for Tokyo, right? Yeah, what's the weather in Tokyo? And it used our tool, called it, and returned rainy 20 degrees Celsius. Rainy 20 degrees Celsius. Perfect. If we switch that to, let's say, London, and run this again. Oh, sorry. Run this. We get the weather for Long John, which is cloudy 15 degrees Fahrenheit. Now let us test out the tip prompt. Let's pass in the tip prompt and pull up our command line, run our file. Try and do that calculation in your head. Oh yeah, the result already came. I was going to challenge you to do that calculation in your head before it's returned, but it returned. Yeah, 20% of $50 is $10. $10. So yeah, that's how tool augmentation works. So in this video, we're going to be looking at another important LLM augmentation, and that's giving our LLMs the ability to produce structured outputs. Like I said, in your applications, most time when you need to communicate from one component to another, or you want to communicate with an external service, you most likely need an output from your LLM to come in a defined format. That can be JSON, that can be XML, it can even be a comma separated string. You just want it to be in a defined format that is expected by the downstream service that is going to be consuming the output from your LLM. So in this video, let's imagine that you have an e-commerce site, and on your e-commerce site, your users are entering. Let me start creating the file for this demo. So your users are entering reviews. And they will definitely enter the reviews as free-form text. They will enter it in free-form text. But you want to be able to take these reviews, take important information from these reviews, and enter it into some kind of scoring system, some performance scoring system, or just some customer churn analysis system or stuff like that that you have as an internal tool, or just somewhere in your application where your business people can look at it and be able to know what the customer's pulse feels like. So we're going to be creating that in this video. We're going to see how we can extract structured output that we can then pass to a downstream service or another component in our application from the output of our LLM. So let's get started with that. First thing I'm going to do is bring in dependencies, and I will start with the LangChain OpenAI package, where we'll import chat OpenAI. Then I will also need a prompt template. So say from LangChain core prompts, we need a chat prompt template. Then, because we're working with structured outputs, like I said, for structured outputs, you need to pass a schema to your model. You need to bind your model's response to a schema. So we need Pydantic. So say from Pydantic, import base model. Like I said, I seem to be having fat fingers this afternoon. So import base model field. Then from typing, let us import a list. We're going to need this in our schema, and let's just import JSON. The JSON package will just be used to print our output. Not like it has any core function it wants to perform in this application. So yeah, so now we have this. And like I said, for a structured output, you need a schema to be binded to your LLM. So let us create that schema. We're going to create a class called product review. It's going to inherit base model from Pydantic. And here we can define the structure that we want our output to come as. So I'm going to say structured product review analysis. No, not Z. Analysis. So as the user sends in their review, the first thing we want to know is the product they're talking about. So say product name of type string, set it to field, and we'll describe it as the name of the product. These descriptions are very, very important so that your model knows the right thing to extract. Then we want to get the customer sentiment, which will also be a string, field, description. I think at this point I'll just copy the description so I can just paste it. So description of this will be overall. There's some quotes there. Overall sentiment. And that will be positive, negative, or neutral. So is the customer happy? Are they angry? Or they just don't really care? So after sentiment, we need a rating. We need the LLM to extract what it thinks the rating is. I want it to be a rating from 1 to 5. So we also want to ensure that it's not going out of that range. So greater than or equal to 1, less than or equal to 5. Next, what are the pros? What are the good stuff we can take out of this review? What are the good things the customer said? That'll be a list of strings. The field. Am I missing something here? Oh yeah, this is not necessary. Yeah, so let's get out. So rating int. Okay, I knew there was something wrong here. Okay. So this also has to be equal to, yeah. So field, the description for the pros is, that will be the list of positive aspects of the review. We also have cons because we like taking criticism. So what are the cons? That will be list of negative aspects. Then we'll like a summary. Yeah, what's the whole gist? Because for some people, for some stakeholders like our board and all that, they just want the highlights. They don't want to get bored by all the details. So description, brief. That'll be a brief summary of the review. So yeah, there's a bunch of typing. Now we have our schema. These are our schema, well defined, and these descriptions help inform the model the type of information that we want to extract from whatever the user has typed in as a review. So let's get our LLM set up. And just as I mentioned when we're doing the tool call augmentation, make sure you're using a model that supports structured outputs. Yeah, make sure. I don't think GPT-4 does. GPT-4o does. It supports structured outputs. But GPT-4, I'm not sure. So be very, very careful the model you're using, else you're going to get an error. So we have our model. Now we need to augment it. How do we augment it? So I'm going to say LLM or structured LLM. That's the LLM we're augmenting. Structured LLM is equal to LLM dot. Now to bind it to our schema, we need to call the with structured output method. With structured output. That is the method that helps us connect our model to our schema so that it can then provide its answers in a structured output or in a structured format. So let us get our schema and put it here. Good. Product review. So anytime this LLM returns a response, it will respond based on this structure. So let us test that out. Let us see how that works. First, let us build a prompt. We're going to build a prompt. Remember, we brought in a chat prompt template. So we're going to build a prompt and say chat prompt template dot from template, not from messages, not from template, from messages. From messages. So here we're going to be adding a system instruction that is going to kind of instruct the model. Yeah, we are taking in a review and we want you to extract it in a structured format. Then the user message is going to pass in the review. So let's start with the system instruction. The system, and we're going to say you are a product review analyzer. A product review analyzer. Extract structured information from reviews. So it's always important to add a system instruction just to further guide the model that this is what we are trying to do. So for the user message, we'll just send in our review text. So that will be the expected input. So review text. That's good. So now we have a prompt and we have a structured LLM. Let's build a chain. So we need to combine these two so that we can then run them together. So for that, we need to build a chain. So I'm just going to say chain. Going to be the prompt. I'll use LCEL to pipe it to our structured LLM. So the input enters the prompt as review text, and the prompt template passes it, and then it gets sent to the structured LLM so we can have our response. So that's good. Now let's pass in a review to this. Now I'm going to be using a review that looks like a real review. So let me just grab that from the exercise files. That's the repo for this course, the GitHub repo for this course, for this file. So you can also get it from there if you're following along. Just grab it. And I'm going to paste it here because I don't want you to see me typing all that. So review copied. Paste it. So these are our review text. I bought this wireless mouse last month and it's been mostly great. The battery life is incredible. I've only charged it once in 4 weeks. The ergonomic design fits my hand perfectly and the buttons are responsive. However, the scroll wheel is a bit stiff and makes clicking sounds. Also, it's quite expensive compared to similar models. Overall, I'd give it 4 out of 5 stars. So this is like a typical review you see on Amazon or any other e-commerce store online. So we're going to pass this through our structured LLM and see what it extracts for us. For that, I'm just going to say result equals chain.invoke. Then we'll pass in a dictionary. And the dictionary expects a review text property. And we're going to pass in our review text. Awesome. Now, because this is going to return JSON, we're going to print it using the JSON module. So I'll say JSON dumps results dot model dump, which is a function we get by virtue of using structured output. So model dump, and we just indent by 2. Okay, then by 2. So let's save that. Pull up our command line. Now let us run this file. O2 into workflows, then O204, which is the video name, and then let us see what we get by running our freeform text review through our structured output. Oh, okay, so I didn't set my model correctly. I was thinking it was trying to say GPT-4 doesn't support that. Yeah, so yeah, I needed to say model here. Model, because I didn't name my input, it probably was thinking it's the API key or something. Or I needed to arguments. Oh, take some position argument, but yeah, sorry. Let us run that again. So, where am I? Run file. Make a request, and boom. We have our structured output in JSON. How amazing is that? So product name, wireless mouse. The sentiment says it's positive. Yeah, it was kind of positive. Rating was 4. That was direct. It was just there. Pros, incredible battery life. It mentioned that. Ergonomic design, responsive buttons. Cons were stiff scroll wheel, clicking sound from the scroll wheel. And the customer also mentioned that it was expensive compared to similar models. And the summary that our model gave us is that the wireless mouse performs well with excellent battery life and comfortable ergonomic design. Despite its higher price and minor issues in the scroll wheel, it remains a reliable choice. So that was, yeah, that's kind of like the summary of everything. So yeah, in this video, we've seen how to augment our LLM with a schema to produce a structured output.